right, we're going to be looking at section 5.7. We're going to start talking about compound interest. Now, compound interest is interest paid on the principal, which is how much you put in, and on previously earned interest. The formula for compound interest is this, okay? You've got A equals P, P is your principal, times 1 plus. Because you have 1 plus, you know that this is exponential growth. Then you have R, which is your interest rate. Now, your interest rate is always going to be in the form of a percentage. What you have to do is change it into a decimal when you plug it into the formula. You'll put that over N. N is the number of times that you compound your interest per year. And then bring it straight up to an exponent and multiply it times your time. Your time is going to be in terms of years. Okay, so A, that's your total amount. That's the principal plus the interest all together. P is the principal. That's what you start with, how much you put in, etc. R is your interest rate as a percentage. N is the number of times you compound per year. And then T is your time in years. Now, as far as N goes, you might see it like this. Might say that you're compounded annually. If you compound annually, you're compounded once per year. If you compound semi-annually, that's twice a year. Quarterly, think of 4 quarters in a dollar. That's 4 times per year. Monthly is 12 times a year, and daily is 365 times a year. Okay, so now let's put this into practice. So, let's look at our first problem here. Maybe. I've got too much paper in here, sorry. So here's our first problem. We are investing $2,000 at an annual rate of 8% compounded annually, semi-annually, quarterly, monthly, and daily. And we want to know how much that will give us after 1 year. So let's write down our formula. A is equal to P times 1 plus R over N to the NT. Now, A, that's how much we're looking for. How much will it yield? How much will it give us after a year? Our principal is going to be the amount that we deposit, which is going to be $2,000. Then we'll have 1 plus. R is our interest rate. Now, if you'll notice, we've got 8%. If you take that 8% and you change it out of its percent form into its decimal equivalent, you're going to move your decimal 2 places to the left. So that's going to give you, as a percent, 0.08. Okay, now N is the number of times you compound per year. The first part of this is to find out how much we've compounded annually. Remember, annually is 1 time per year. Now bring that 1 up and multiply it times your time in years, which is also 1. So actually what we have here is 2,000 times 1 plus 0.08 or 800ths. Because if you're dividing by 1, or have an exponent of 1, then you really don't have anything. So let's go to our calculator and turn it on, and we're going to type in 2,000 times, really, in the end, 1 800ths. Okay, and that's going to give us $2,160. So A is equal to $2,160. Okay, now the next part of this is to find out what we're going to make if we compound semi-annually. So to compound semi-annually, we'll have P is 2,000 times 1 plus our rate, which is still 800ths, over semi-annually is 2 times per year. Okay, so let's plug this into our calculator. We'll have 2,000 times 1 plus our interest rate over 2 raised to the second power, because 2 times 1 is 2. So that's going to give us A equals $2,163.20. Okay, so that's number 1, that's number 2. Now the third one is quarterly. So on the third one, we'll have 2,000 and 1 plus our interest rate. Now, if you're going to compound quarterly, that's going to be 4 times a year. So you'll raise that up to the 4 times 1. Okay, now going over here, we'll have 2,000 times 1 plus our interest rate over the number of times we compounded raised to 4 times 1, which is just 4. So that's going to be $2,164.86. So A is equal to $2,164.86. All right, number 4, A equals 2,000. Now we're going to do monthly. So we'll have 1 plus 0.08 monthly is 12 times a year. Okay, so let's go to our calculator. We'll do 2,000 times 1 plus, once again, our interest rate over the number of times we compound per year, raised up to the 12 times 1, which is 12. $2,165.99, so that's going to be $2,166. Okay. All right. So the next one is going to be daily. Okay, so when we do daily, this is the 5th one, we'll have 2,000 times 1 plus our interest rate over daily is 365 times a year. So that'll also be our exponent. Okay, let's go over to our calculator. We'll have 2,000 times 1 plus our interest rate over 365 times a year. Then raise it up to 365 times 1. So $2,166.56. Okay, so you see that we started off compounding 1 time a year and we have a balance of $2,160. Since we started off with $2,000 in principal, that means our interest was $160. Here, when we're compounding semi-annually, our interest is $163.20. And then you can see our interest is $166.56. $166.56. Okay, so as we compound more, we make more money. Okay, but just remember, in your formula, this is always your principal. This is what you start off with. This is your interest rate as a decimal. This is the number of times that you compound per year, and you also bring it up as your exponent. Now your time has got to be in terms of years. If it is not, fix it. Okay? Now let's move on and let's look at the next thing on our list, which is going to be continuously compounding interest. Now, in the previous problem, we used 1p times 1 plus r over n to the nt because we compounded at a specific time, yearly, semi-annually, monthly, daily, whatever. When you compound continuously, you have to use the letter E. Remember, the letter E represents a number for us in math. So if you think about the letter E, it's 2.71828 and then some extra stuff. So it has value, but it's still going to be exponential growth. But anytime you use compounding continuous, you will replace 1 plus r over n with E. Okay, and you won't have to the nt, you'll have to the RT, which will be your rate times your time. So in this particular problem, the amount that results from investing $1,000 at an annual rate of 8% compounded continuously, that means all the time, over and over and over, for a time of 1 year. So let's write down our formula. A equals P times E to the RT. A is how much money we're going to have when we plug in a principal of $1,000. Now my rate here is 8%. Remember to take your interest rate and move your decimal 2 places to the left. and multiply it times your time, which in this case is 1. Okay, so let's go to our calculator and we'll have 1,000. Now when we use E, make sure you go to second and then hit the natural log button. Okay, so second and natural log, because E to the exponent is there. If you just want to remember what the value of E is, you do second and divide. Okay, you see the difference here? This is second and divide, it just tells you the value of E. But second natural log will give you E to a power. Now our power is 0.08 times 1, which is just 0.08. So you can see at the end of 1 year, our $1,000, if it's compounded continuously, will give us $83.29 interest. Okay, so our total amount, A is always the total, is $1,083.29. Okay, and you can subtract 1,000 from this to get the amount of interest that you actually earned. And that's the formula for continuous compound interest. Okay, so let's move on and see what's next. Okay, then next is the effective rate of interest. When you're out shopping for a bank that will give you the best bang for your buck or the best interest rate, if they're compounding your interest, you might have one bank doing 2% compounded monthly or 2.5% compounded yearly. How do you know which one's the best? Do you look at how many times it's compounded a year? Do you look at the interest rate? What? Well, the effective rate of interest will actually help you decide by changing all of those interest rates into one continuous rate, or a rate that's even across the board for all three of them. So what your effective rate of interest is, if you're just compounding a regular amount, you've got R subscript E, effective rate of interest. You still have 1 plus R over N, just like you did before, raised to the N. What's dropped is, of course, your principal and your time. And then you take all of this and subtract 1 from it. Now, if you have continuous compounding, you're going to have E to the R, but again, the T, the time is dropped, and the principal is dropped, and you're going to add that minus 1. So take a moment and copy these two formulas down. And remember, we use these when we're comparing the interest rates and the different compounding amounts from different banks to see which one is going to give us the best amount in the long run. Okay, so which is the best deal? Suppose you want to buy a 5-year certificate of deposit, that's called a CD. You visit 3 banks to determine their CD rates. American Express offers you 2.15%, but it's going to be compounded monthly. First Internet offers you 2.2% compounded quarterly. Discover offers 2.12, but it's compounded daily. Determine which bank is offering the best deal. So if we use our effective rate, R of E, let's go to the first bank first. That's going to be American Express. Okay, so we're looking for R of E. Now it's going to be 1 plus our interest rate as a decimal. We've got 2.15%. And if you move that over, it'll be 0.0215. And then N is the number of times you compound a year. We're compounding monthly. And then raise that up. Again, we're dropping the P and the T, but don't forget to subtract 1. Okay, now let's set up for, we'll go to our calculator in just a moment. Let's look at First Internet Bank, okay? So they'll have 1 plus our percent as a decimal, move that 2 places to the left. So that's going to be 0.022. This one is compounded quarterly, that's 4 times a year. And don't forget to subtract 1. And then finally we have Discover. So Discover Bank is going to be 2.12. So move that 2 places to the left. And that'll be 0.0212. It's going to be compounded daily. That's 365 days a year. And don't forget, subtract 1. So let's plug all this information into our calculator. Okay, now for the American Express, we're going to have 1 plus 0.0215 over 12, and we are going to raise that to the 12th power. And I forgot to subtract 1. Okay, now what you see right here is a decimal, and we're going to have to take this and change it from a decimal to a percent. So to do that, we won't go to the right, but instead we'll go to the left. Let's go out 3 decimal places, so 2.171%. Okay, now my next one will have 1 plus 0.022 over 4, and that's going to be raised to the 4th power, but don't forget to subtract that 1 like I forgot last time. Okay, so move that out to 2 decimal places. That'll be 2.22%. Oh, I've been going out 3, haven't I? 2.218. Sorry about that. So 2.218. All right, and now for discover, 1 plus 0.0212 over 365. Raise that up to 365 and subtract 1. Okay, so go out 2 decimal places. That'll be 2, or move it 2 decimal places, 2.143. Okay, so looking at your 3 effective rates of interest, you can clearly see that First Internet Bank is the one that you need to go with, okay, because you ended up with 2.218%. Okay, so this is the bank that will give you the best deal, will give you the most yield for your money on your CD. So anytime you're looking for the best rate, use the effective rate of interest. So the bank that offers the best deal is the one with the highest effective interest rate. Okay, so moving on to our next formula, we have the present value formula. If you will notice, present value is your P in your compound interest formula. So it's your principal, okay? So it's also referred to as present value. What about that? So what happens in the formula, if you'll notice, P and A have been swapped, haven't they? And then your exponent is negative. Everything else is the same. In continuous, P and A have been swapped and your exponent is negative, but everything else is the same. So you use this formula when you're given your total amount, your A, and you're looking for P, your principal, which again they refer to as the present value amount. Okay, so let's work out a problem. We have a 0 coupon, which is a non-interest bearing bond. It can be redeemed in 10 years for $1,000. So the $1,000 isn't your principal. Okay, that's what it's going to be worth 10 years from now. How much should you be willing to pay for it now if you want a return of 7% compounded monthly? So the formula for actually finding P instead of A is going to be P equals A times 1 plus R over N to the negative NT. Okay, switch your A and your P and make your exponent negative. So the principal is what we're looking for. A, which is going to be your total amount, is what we have. We know that this is going to end up being a $1,000 bond. And then 1 plus our interest rate is at 7%, so that's 0.07. And we're going to compound that monthly. That's 12 times a year. And don't forget to make it negative. And your time is going to be 10 years. Always make sure your time is in years. So when we go over here to our calculator, we have 1,000 times 1 plus 0.07 over 12, and then raise it up to the negative 120, because 12 times 10 is 120, and again it has to be negative. So this is money we're dealing with. So your principal, or how much you should invest into this bond at the present value or the present time, is $497.60. Okay, see the 6 rounds the 9 up, which will round it up to 60. Okay? Now, let's look at the same situation, but we're going to compound continuously at 6% interest. So P is equal to A times E to the negative RT. A and P are switched. R and T has been changed to a negative. So the principal is equal to the ending amount, which is 1,000, times E to the negative. Take your 6% and change it into a decimal and multiply it times your time, which is 10 years. So as you plug this into your calculator, you'll have 1,000 times E, so do second natural log, to the negative 0.6. Okay, 600 times 10 is going to give you 6/10 and make it negative. And so that's going to give you $548.81. So when you're using this formula, you know what your balance is going to be in the future. You're looking for what you need to invest right now. Okay? All right, and that's the last formula that we have, but we do need to look at how to double and triple our investments. Okay, so looking at this very first problem here, it says, what annual rate of interest compounded annually is needed in order to double an investment in 7 years? So this is compounding annually. So we're going to have A, which is the total amount, equals P times 1 plus R over N to the NT. You see, we're not looking for the principal, okay? We don't even need the principal in order to solve this problem. So we don't have to use our new formula that we just wrote down with the negative exponent. We just need the original compound interest formula. So what annual rate of interest, we're looking for R here, it would appear, is needed in order to double an investment in 7 years. So if you double your investment, that's your P, okay? That's your principal. That's what you put into it. That's what you started with. So if you're going to double your investment, whatever P is, it's going to be 2 times P. So A is going to become 2 times P. Now, it also says we're going to be compounding annually, so N is 1. And it also says 7 years, so T is 7. So what we end up with is 2P equals P times 1 plus R to the 7th power. Because R divided by 1 is R, and 1 times 7 is 7. Now let's solve for R. First thing I see is that I can get rid of this P by dividing both sides by P, and both of them will cancel out, which is kind of the point. And then I need to get to the R, but I can't because it's raised to a power of 7. Well, I know how to get rid of a 7th root. I will take the 7th root on both sides. So here I'll have the 7th root of 2 is equal to the 7th root of 1 plus R to the 7th power. Those two undo each other, and you're left with 1 plus R. Now subtract 1 from both sides. And this is my interest rate. -1 plus the 7th root of 2 equals R. Well, that doesn't help me much percentage-wise, does it? So what I'm going to do is I'm going to hit -1 plus, and then I'm going to hit my math button. If you look at number 5, you'll see that's any root, and that's what I need. So I need the 7th root of 2. So once I plug this in, that'll give me my rate. But it gives me my rate as, you guessed it, a decimal. So what I'm going to do is I'm going to move my decimal 2 places to the right, and I'll get 10.41%. I'm going to do 2 decimals this time. So 10.41% is my interest rate. And I found that by knowing if I'm going to double my investment, that means I'm going to have double the principal when I'm finished. So I replaced A, which is my finished amount, with 2P. And then I was able to divide away the P's. And once I did that, that only left me with my variable r, which I was able to get rid of. Now we're going to do pretty much the same thing on this next one. Okay, it says, how long will it take for an investment to double if the value it earns 6% in value, if it earns 6% compounded continuously? So continuous is P times E to the RT. Now we want to double our investment again, so we're going to replace A with 2P. Okay, and it also tells us that our interest rate is 6%, so I'm going to change that to 0.06. And it says how long, that means the time is what we're looking for. So notice that I replaced A with 2P, because once again we're going to double our investment. And then I replaced my rate with 0.06, which is my percent as a decimal. And then my time is what I'm looking for. Okay, so let's divide both sides by P, and we'll get 2 is equal to E to the 0.06t. Okay, so we got a problem this time. The last time we were able to square root and we were able to get rid of our exponent altogether, and it was great. So I took the 7th root on both sides, everybody was happy. Can't do that this time because my exponent is the variable. But luckily we just learned how to fix that. So if I want to get this t down, what I'm going to do is I'm going to take the natural log on both sides. Because remember, the natural log is log base e. So you got log base e of e to the 0.06t. If these two match, this is your answer. So you have the natural log of 2 is equal to 0.06t. Now solve both sides by dividing by 0.06. Okay, so if I go to my trusty calculator and I do alpha x, I'm going to do the natural log of 2 over 6/100. Okay, and that's going to be my time. It's going to be approximately 11.55 years. Okay, so a little over 11.5 years. So 11.5 years is 11 years, 6 months. So it'll take you 11 years and 7 months on this one.